this rover design, my partner and I designed a space rover inspired by NASA's Perseverance rover. We created a realistic rover design that can withstand the climate and geographic strains of the planet, so further exploration can be done. For the suspension, there are free-running H9D9 holes to connect it to the chases, which have a standard fit of 90 millimeters. The hole tolerance is 0.015 millimeter and the shaft tolerance is 0.009 millimeters. These values allow the suspension to rotate freely, increasing the mobility of the rover as it travels across the rough terrains of Mars. This plutonium-based radioisotope thermoelectric generator, or RTG, is the energy source for our rover. It takes in the solar energy captured by the panels and uses it to power the rover, allowing the rover to use all its functions to the fullest. The tolerance is 0.087 millimeters for the hole and 0.12 for the shaft. The high-gain antenna gimbal is used for direct communication with Earth-based stations. When used with the UHF electrolyte transceiver, which relays proximity-based data, the antenna range is around 1,000 kilometers. The arm assembly allows for the rover to pick up and collect any interesting samples that it may come across. These samples can be transported back to NASA along with the rover at the end of its Mars journey, where further examination can be done. This camera will capture everything the rover passes on its routes. This camera may be accessed during or after the rover's time on Mars. This way, if there are any big objects that the rover cannot carry with the arm, the camera has it documented. The bolts and screws used here have transition fits, and so do these. This is our drawing for the chases, suspension, wheel hub, solar panels, plutonium, gimbal screw bolt, transceiver screw bolt, arm, mast.